Welcome back to the ISNaDBiblio tutorial series. In Module 17, we examine RPYS, short for Reference Publication Year Spectroscopy. This method traces the publication years of every entry in the reference lists in order to uncover the older works that form the intellectual roots of a field. Let us begin by opening the RPYS menu in the Citation Analysis group. Notice that what we analyze here is not the articles in your dataset. It is every reference cited by those articles. There are usually far more of them, and their year range reaches much further back. The underlying idea is simple but powerful. If many present-day articles cite work from a particular year, that year must hold something important. RPYS counts how many references fall in each publication year. It then compares that count with the median of the surrounding years. This deviation from the median is what produces the peaks on the chart. Now look at the chart itself. The horizontal axis is the reference publication year, and the vertical axis is the deviation from the median. Every prominent peak marks a year that produced an unusually influential work. A tall peak usually points to one or two classic works that everyone cites in common. There are two ways to compute the deviation. Centered mode compares a year with the 2 years before it and the 2 years after it. Backward mode compares it only with the years that came before. Backward mode is more sensitive to newer work that suddenly attracts a burst of citations. Further down, you will find a list of the most historically influential works. This is your required reading list if you want to understand the theoretical foundations of the field. Interestingly, many works on this list never appear in the Top Documents module. That is because they were published long before your dataset range, yet they are still cited today. With that, we have walked through everything in the RPYS module. You can now trace the historical roots of your field of study. In the next module, we examine co-citation and bibliographic coupling. See you there.